Friend 1, hey, can you explain to me what a relation is in math? Friend 2, sure, I can do that. A relation in math is a set of ordered pairs. Each ordered pair consists of two elements, and the order of the elements matters. For example, the set 1, 2, 2, 3, 3, 4 is a relation. In this relation, the first element of each ordered pair is less than the second element. Friend 1, so, a relation is basically a list of pairs of things? Friend 2, yes, that's right. But the order of the things in each pair matters. For example, the set 1, 2, 2, 3 is a relation, but the set 2, 1, 3, 2 is not a relation. This is because the order of the elements in each pair is different. Friend 1, I think I'm starting to understand. So, a relation can be used to represent any kind of connection between two things? Friend 2, yes, that's right. Relations can be used to represent all sorts of things, such as the relationship between parents and children, the relationship between teachers and students, and the relationship between numbers. Friend 1, can you give me some examples of relations? Friend 2, sure. Here are a few examples of relations. The relation is less than on the set of real numbers. This relation can be represented by the symbol. For example, the statement 2 less than 3 is true because 2 is less than 3. The relation is a parent of on the set of all people. This relation can be represented by the symbol p. For example, the statement p, John, Mary, is true because John is a parent of Mary. The relation is divisible by on the set of positive integers. This relation can be represented by the symbol d. For example, the statement d, 12, 3 is true because 12 is divisible by 3. Friend 1, okay, I think I understand now. Thanks for explaining it to me. Friend 2, you're welcome. I'm glad I could help. Sure thing. Let's dive into the world of mathematical relations through a conversation between two friends, Sam and Alex. Sam, hey, Alex, I've been reading about relations in math lately, and I'm a bit confused. Can you help me out? Alex, of course, Sam. I'd be happy to. So, a relation in mathematics is basically a connection between sets of values. It's like a rule that tells us how elements from one set relate to elements in another set. Sam. Sounds a bit abstract. Can you give me a concrete example? Alex, definitely. Let's say we have two sets. Set A is 1, 2, 3 and set B is x, y, z. Now, imagine we have a relation R from A to B, denoted as R-A-B. Sam, hold on. R-A-B? What does that mean? Alex, good question, Sam. That notation just means that R is a relation from set A to set B. It helps us understand that we're looking at how elements in A are related to elements in B. Sam, got it. So, how does this relation work? Alex, let's define our relation R. We'll say that each number in set A is related to a corresponding letter in set B. Following a simple rule, multiply the number by 2 to get the corresponding letter. So, if we take 1 from set A, it's related to 2 in set B. 1 times 2 is equal to 2. Similarly, 2 is related to 4, and 3 is related to 6. Sam. I see. So, R is like a rulebook that tells us how to pair up elements from these sets. Alex, exactly. And now, we can represent this relation as a set of ordered pairs. In our case, it would be 1, 2, 2, 4, 3, 6. Each ordered pair represents the relationship between a number in A and its corresponding letter in B. Sam, this seems straightforward. But can relations be more complicated? Alex, absolutely. Relations can get as complex as you want. For instance, consider a new set C as red, blue, green. We can create a new relation, let's call it S, from A to C. Sam, how does S work? Alex, let's say S relates each number in A to a color in C. We can define it like this: if the number is even, it's related to blue; if it's odd, it's related to red. So, 1 is related to red, 2 is related to blue, 3 is related to red, and so on. Sam, interesting. So, relations aren't just about numbers, they can involve different types of elements. Alex, absolutely. That's the beauty of relations. They can connect elements from any sets based on some rule. And the rule doesn't always have to be a straightforward formula, it could be anything that defines a connection between elements. Sam, alright, I think I'm getting the hang of it. But why are relations useful? Alex, good question, Sam. Relations are a fundamental concept in mathematics, and they're used in various branches like algebra, calculus, and computer science. They help us model and understand how different things interact with each other. Sam, any real-life examples? Alex, definitely. Think of a simple example like a is-friend of relation on a social media platform. If we have a set of users, the relation could tell us who is friends with whom. It's like a social network graph where the nodes are users, and the edges represent the is-friend of relation. Sam. That makes sense. So, relations are not just abstract, they can model real-world connections. Alex, exactly. They provide a powerful tool for describing and understanding relationships, whether in mathematics or in our day-to-day lives. Sam, thanks, Alex. I appreciate the explanation. Relations seem less daunting now. Alex, no problem, Sam. Math can be tricky, but breaking it down into conversations like these often makes it more manageable. If you ever need more help, I'm here. Sam, great, I'll keep that in mind. Thanks, friend.